Okay, this is our second video of building up the diffusion here, and we just reset it and start it again. We have now cells that are going to be able to talk to their neighbors and diffuse chemicals. We can see that happen if I just go step by step. This cell talked to all 8 of its neighbors, and it had lots of stuff and they had nothing. And so they looked at the average around them and took 1/9 of that. And everybody is doing that here as well, just spreading and spreading and spreading out to all of those neighbors, slowly and slowly, using these evaporation rate and diffusion rate that we were talking about in our model code. Okay, so next thing we want to do is actually make the model. We have our agent, we have our environment. Let's go make our model. So model.py is going to need to import from Mesa the model class. So capital M for model. Great. Okay. Let's make our diffusion class based on the model. Now this model has tons of stuff that it's going to be able to do, and we also want to build in some other pieces here. Let's do it step by step here. So our initializer, self, and then here's where we put all the parameters of the model. I find it helpful, according to how Mesa has been defined, to include a lot of default parameters. Makes it easier to run the models later. But evaporate equals 0.07, for example. Diffusion equals 0.3. And then we have let's say init drop is 500 and lower bound is 0.01. Okay, so this is our init. And first thing we need to do is talk to the super again. We are not just a class, we are a Mesa model. And so we need to go make sure everything gets set up according to the Mesa model super. Okay. Here is the next part. We generally record all of these different parameters so that everybody else can see them. These are our globals. They're global to the model. They have a location where they live. So self.evaporate equals evaporate. Self.diffusion equals diffusion. Why did you capitalize that? Self.init drop equals init drop. Self.lower bound equals lower bound. Okay, so all of these parameters that are coming in, I save them, I remember them. Next thing we need to do, the model needs to talk about time and space. Mesa has great classes to do that. So from mesa.time, our model needs to import simultaneous activation. And then from mesa.space, we're going to import the single grid. So let's see how we set those up now. Okay, we need to know time. Our model is going to ask these agents in our environment to do something every step. So we need a schedule equals simultaneous activation and pass it the model. So when this gets called and has something to do, it will know what model it's talking about. Okay, self.grid. I want you to be that single grid. Means the things out there are going to have one thing in it, height and the width, and is this a torus or not? It is helpful to find, yes, this diffusion, we are going to pass things around the edges. It's going to be a donut for us. So we have set up a schedule and we have set up a grid, a time and a space for our agents. Okay, let's add our agents in there. So for contents x, y in self.grid coordinate iteration, what is this going to do? We're talking to that grid that we made, and we say iterate through all the coordinates in the grid. We gave it a height and a width, and so now we get these things back, contents x and y. What am I going to do with it? There's nothing in the contents right now, so I'm pretty much going to ignore that. But the x and the y numbers are going to be important. I need to make a cell based on the environment and give it a position, x and y, and give it the model. That's what I required. When I made an environment, I said position, model, here's where those get added. Okay, so I am going to self.grid place the agent I just made at the position x, y. This tells the grid you have a model, you have an environment, you have a cell that you are responsible for. Here's an agent in a position. Okay, also we need to add it to the schedule. So now our environment agents that we made exist in space and they exist in time. This is critical. Okay, so now some of those that we just made, we are going to place some chemical just to make the model get going. So conveniently, the model that we make here has a random number generator. That is helpful for keeping track and seeding things and making sure that the randomness is called just in one place. So if you have random numbers, you always want to go to your model and you put them together. And we're going to say, hey, if a random number gets flipped and 1% of the time, we're going to make some of those cells get some chemical. So add a certain amount of chemical to that spot. Okay, last thing we do for our model is say it's running. Our model is ready to go. Self.running equals true. Okay, so because we added the model to the schedule, the model needs to have a step. And the step is going to be calling back, hey, self.schedule dot step. Someone says, hey model, it's your turn to do something. The model goes and talks to the scheduler, and the scheduler calls the step method of the schedule. And because we added every cell to the schedule, it is essentially a for loop that is going to run through, and it's a simultaneous activation. So first it calls step, and then it calls advance. Okay, so we have an environment agent, and we have created a diffusion model. Now one last thing, I created an environment object here, but I didn't really import the right things yet. I need to say from.agent import environment. Okay, cool. I misspelled environment, but I think I consistently misspelled it everywhere I used it, and so it should be fine. Okay, so the last thing we want to make in the next video is the server, the pieces of code that are going to make it show up on the screen in this fashion so that I can have my sliders and I can run my start and do some other things. That's the server's responsibility.